What's going on, YouTubers? Welcome back, my friends. I'm excited once again. Welcome. I got something new, and this time it's PEMF 1B circuit, but updated. Here it is. It's got some features, some unique features that I would like to show you guys. And what I'm thinking is this circuit will be second version of PEMF 2B. So in addition to the previous circuit, this one here, what this circuit has is a burst circuitry. Basically, it's a piece of circuitry that monitors current flow, and when it reaches to certain amperage, it triggers the relay here, and this relay mutes the signal that's coming out from the pulse width modulator, and it mutes it to the ground, so it stops the pulsation. And that's the idea, is to when you crank it up on here to, let's say, 30% on duty, and you go down to low frequencies, for example 5 Hertz or lower than that, you'll put quite a bit of load onto the transformer. And so to prevent overloading transformer, this circuit is designed to be here. So it monitors the current. When the current exceeds, it mutes the signal. In addition to the previous circuit, I have power meter right here, and the function generator PWM is a newer style that has this twist knob, and it has some cool features, which are preset settings. You can preset maximum duty, and it won't go whenever you twist this knob here. It will go to the maximum preset setting, and it won't go over. And I like that compared to the previous models that I used with the buttons here. In this circuit I'm using 2 ohm coil. It's 18 gauge, around 1.5 pound, 2 pounds. Same transformer, 70 volt transformer, 4 amp, which is 240 watt, 280 watt. And then I use 12 volt adapter. It's 3 amp here, but you can use lower than that. You can use 1 amp. It's for the low voltage circuit to run properly. So in here I have a blocking diode, reverse blocking diode, and a MOSFET here. This is 130 amp MOSFET here. All this circuit, the printed circuit board, and the layout, and the connection of all the components, I will make another video and I'll show you how I have designed everything in the back and connected everything. Let me show you quickly how it looks in the back. This is the back side of the board. This is my very first prototype. That's why it has these jumpers, and I'm still like making adjustments and correction, make sure this works correctly. So far it's been working like a champ. I like it. Alright guys, let's power it up and test it, see how it works, see how it performs. Alright, you guys ready? 1, 2, 3. Here we are. So right now we're pulling 11 watt. That's the standby current of the transformer and all this circuit. It's consuming about 10 watts of power when it's not operational. We have 119.7 volts coming in. We're driving right now 0.2 amps, and this is the total power consumption here. This is pulse width modulator. This module will generate frequency that will be used for the coil, pulsate into the coil. So right now it's set for 10 Hertz and 13% on the duty. Alright, circuit. We have a green LED on, and we have a red LED on. Red LED indicates that signal is coming through, it's not being blocked. And then we have a pulsation LED. I'll show you how that works. Whenever we apply a signal, the LED will pulsate. Alright, let me grab my Tesla meter. We'll take some measurements. Alright guys, so what I wanted to show you is when you pulsate at low frequencies like 1 Hertz, you don't need to have a high duty. All you need is about 2%. 2% is all sufficient enough to pull all the juice out of these capacitors in a single pulse. If you put more than 1%, you're gonna overload your system, so do not do that. When you get to about 10%, then you can raise it up to 10%, 15% on the duty, but not when it's 1%, not when it's 1 Hertz. You cannot go 15% on duty. So let me show you guys. This is 1%, 1 Hertz. Let's take a Tesla meter and let's take a measurements. So I have my Tesla meter here. It's tape. Alright, I have a power button. As I said, 1 Hertz, 1%. Check it out guys. 1, 2, 3. There we are. So 0.343 Tesla. And then if I increase the duty to about 5%, okay, so it was 1%, now it's 5%. Take a 1, 2, 3. See, it only went up to very little. So there is no point on raising high duty when you go low percentage. And so we're getting 0.34 Tesla. That's 3,470 Gauss coming out at 1 Hertz. So let's raise up to 10 Hertz and take a measurements. In duty we'll go 10% duty and we'll go 10 Hertz. Reset the volume. Okay, 10 Hertz, 10%. 1, 2, 3. Alright, you see guys, 0.369 Tesla, 3,690 Gauss. And let's increase the duty. Let's increase the duty to about 20%. And let's take one more measurements. Count 3. 1, 2, 3. Alright, so 0.374 Tesla, guys, at 20%. So 10% is sufficient enough to pull all the energy out of this capacitor bank, and we don't need to go to 20%. But I will show you how this burst circuit works here. And when I increase to about 30% on duty, and when I latch this button, we'll see how the burst circuit work. So right now I have created a scenario where I will overload the circuitry. I will pull more than it can supply, and continuously supply, so the circuit will start storing the energy into the capacitor bank and then unloading it into the coil, and then it will shut the coil off, store some more energy into the capacitor bank, and then we'll unload it into the coil again. Alright, once we're ready, on count 3, 1, 2, 3. Here we are, getting 0.38 Tesla, 30%, and the burst circuit cuts about 300 watts. When we get to about 300 something watts, it will get the cutoff. Now, if you listen, you'll hear how load being applied on the transformer and the noise it produces. Alright, I'm gonna shut this off because coil is getting hot already. This is a 2 ohm coil. It seems like it needs to be larger because this circuit is pretty strong. You can heat this coil up to over 100 Celsius in probably less than a minute. Okay, so one more frequency that I would like to test is the highest frequency, which is 600 Hertz, and we'll go 600 Hertz. Okay, we're at 600 Hertz, 30% on duty, and I'll reset my volume, and we'll take a measurement on the count 3. 1, 2, 3. We're now bursting. We're putting out 1230 Gauss, and we're pulling 260 watts of energy, and we're at 600 Hertz. Alright guys, couple more things, couple more tests I would like to show you, so just stand by. Okay, so I got aluminum weight. This is 210 gram piece of aluminum. I'll place it over the coil. We'll go 1 Hertz, which will give us the highest output, and about 2%, which is sufficient enough to drain all the capacitors in a single pulse. I count 3. 1, 2, 3. There it was. 1, 2, 3. Alright guys, one more test with aluminum, and count 3. 1, 2, 3. 2 sheets of aluminum, actually 128 sheets of aluminum, 40 gram of aluminum. 1, 2, 3. 1, 2, 3. Just showing you guys what it is. The coil is already hot. One more test. 10 Hertz, 10%. Blind rivets. very loud, just like here we are. Okay, that's my video for today. If you found this interesting and like it, please give me a thumbs up, subscribe, hit the bell, and I'll see you in the next one.